Alrighty, in this video we are going to be talking about inverse trig and introduce a little bit of compositions of trig functions with inverse trig. Now, as a reminder with an inverse function, your inverse function needs to be one-to-one for inverse trig. Now, remember back in pre-calc, the definition of a one-to-one function is when every unique element in the range maps up to every unique element in the domain. Looking at sine, cosine, and tangent here, we're going to see that they are not one-to-one. So what we need to do is make it one-to-one by restricting our domain. So notice how here, for our sine function, our domain, and for our cosine function, our domain is just our real numbers. What we're going to do here, specifically for our sine and cosine function, is restrict our domain so that it's between, let's say, negative pi over 2 to pi over 2 here. So that's 1-to-1. And from 0 to pi here, so that it is 1-to-1. Now, there is a reason why we're doing it from negative pi over 2 to pi over 2 and from 0 to pi. So thinking back in pre-calc, remember that whenever we talk about inverse sine and inverse cosine, that we have a restriction in terms of my range. So if I think about inverse sine here, remember that inverse sine should only be in quadrants 1 and 4 for inverse sine. And then remember that for inverse cosine, we should only be in quadrants 1 and 2. And then for tangent, it's basically the same thing for sine, except we don't include negative pi over 2 and pi over 2. So also make note of that. So looking at my sine function here, my restricted domain is going to be from negative pi over 2 to pi over 2. So whenever we sketch inverse sine and find the domain and range, remember that the domain of inverse sine is going to be my range here. So that's going to be from negative 1 to 1. And then my range for inverse sine should be my restricted domain of negative pi over 2 to pi over 2. To sketch this, I'm just going to go ahead and switch my x and y coordinates. I'm going to tell you in advance, I'm not the best at sketching this, so bear with me. We have negative pi over 2, negative 1, which becomes negative 1 and negative pi over 2. So I'm going to put that right here. We also have 0, 0. And then we also have pi over 2, 1, which becomes 1 pi over 2. And then looking at your concavity here, notice how this one is concaving up. So our inverse is going to be concaving down. We're just going to look at this right here, something like that. And then here, from 0 to pi over 2, we're concaving down. So our inverse is going to be concaving up like that right there. And that gives us inverse sine. Looking at inverse cosine, remember how we said that inverse cosine is in quadrants 1 and 2. So notice how here my restricted domain is going to be from 0 to pi. Meaning that my range is going to be from 0 to pi, and then my domain is going to be from negative 1 to 1, since that was my range for my regular cosine function. I'm going to go ahead and sketch inverse cosine, so it's going to look something like this here, where I have, let's see, 0, 1 becomes 1, 0. Pi over 2, 0 becomes 0, pi over 2. And then pi negative 1 becomes negative 1 pi. Okay. And then we'll just try and sketch this, and see what goes on here. Something like that, all right? Right. For your tangent function here, notice how your domain isn't all real numbers because we have asymptotes at every pi starting at pi over 2. So pi over 2 is my starting asymptote. And then because my period for a tangent function is pi, my domain is going to be all real numbers except pi over 2 and every pi interval. So that backward slash just means that I'm not including pi over 2 plus pi k. My restricted domain here is going to be from negative pi over 2 to pi over 2, like we said here, in terms of my little drawing, except I'm not including pi over 2 and pi over 2. I'm not including negative pi over 2 and pi over 2. So I should have parentheses there. My domain here is going to be all real numbers because my range here was also all real numbers from negative infinity to infinity. So my domain, negative infinity, infinity, all real numbers, whatever you want to call it. There you go. And then my range is going to be my restricted domain. And then if I were to sketch the inverse tangent here, we are going to have asymptotes at pi over 2 and negative pi over 2. Just like that. All right, so whenever we are looking at compositions of trig functions, you want to make sure, especially for your inverse functions, that your answer is in the principal range here. So remember, for inverse sine, your answer should be in quadrants 1 or 4. For inverse cosine, your answer should be in quadrants 1 or 2. So looking at inverse sine of 11 pi over 6, you might think that the sines will cancel out. And theoretically, they should cancel out, but it's just that your answer, though, would be 11 pi over 6. And the thing is, 11 pi over 6 is not within my range for inverse sine. Because remember, inverse sine is negative pi over 2 to pi over 2. So thinking about my coterminal angles, I'm going to change 11 pi over 6 so that it is negative pi over 6, which is our answer for the first one. Now, if I were to do this without thinking about how sine and inverse sine are inverses of each other, and I were to think about sine of 11 pi over 6, we know that sine 11 pi over 6 is negative 1/2. So I need to think about where inverse sine is negative 1/2. And that would be at 7 pi over 6, which we don't care about the third quadrant, and 11 pi over 6, which is in quadrant 4. But remember, 11 pi over 6 is not in our range. So that's why our answer here is negative pi over 6. We're going to do the same thing with inverse tangent of cotangent 5 pi over 6. We want to figure out where cotangent of 5 pi over 6 is. Remember that cotangent is x over y. So if I think about pi over 6, our coordinates would be root 3 over 2 and then 1/2. And since this is in quadrant 2, I should have a negative x value right here. So simplifying that, I'm going to get negative root 3 over 2 over 1/2, which is the same thing as negative root 3. Okay, so with negative root 3, I need to think about inverse tangent of negative root 3 and where that is. So if I were to think about that, it's either going to be in quadrants 2 or 4, but remember how with inverse tangent, it should be in quadrant 4 right here. So I'm going to say that would be whenever I have 1/2 negative root 3 over 2. And that is 5 pi over 3. The problem is 5 pi over 3 is not in my range because remember inverse tangent is negative pi over 2 to pi over 2. So this right here becomes negative pi over 3. So 5 pi over 3 becomes negative pi over 3 as our answer. Now, sometimes, looking at number 3 here, sometimes you might not have unit circle values, and what you have to do is probably draw a triangle based off of the information that you are given. Now, we are given a sine of inverse cosine of 2 root 10 over 7. Now, for this particular question right here, we need to think about where inverse cosine is located. In this case, we know that inverse cosine is in quadrants 1 and 2. And then we also need to think about where regular cosine is located. Remember how, well, let me go ahead and do this. Inverse cosine is in quadrants 1, 2. And then for my regular cosine function is positive, since my argument is positive right here. That is in quadrants 1 and 4. I don't know why I had to do that. So we are going to make our triangle based on the fact that inverse cosine is in quadrant 1 and cosine is positive in quadrant 1. So I'm going to make my little triangle right here. What I'm going to do now is place the theta right here. And what I'm going to do here is think about how if this right here was theta, so my inside argument, if that was theta. So I need to think about where inverse cosine is in terms of my little triangle. Remember that cosine is adjacent over hypotenuse. So what I'm going to do here is do 2 root 10 and then 7 right here. That way, whenever I write cosine, I'm going to have cosine theta is equal to adjacent over hypotenuse. And then to find theta here, I'm going to have to take the inverse cosine. And this right here is what my inner composition is, which is what we want. Now, the question, though, is asking us what sine of theta is. In this case, sine of inverse cosine of 2 root 10 over 7. Now, remember that for sine is opposite over hypotenuse. I have a problem, though. I don't know what my opposite is. So what I have to do here is use our good old Pythag to figure out what my opposite value is. So now I have, let's see, 2 root 10 squared plus x squared is equal to 7 squared. This is going to give me 40 plus x squared is equal to 49. X squared is equal to 9, which means that my height here is going to be 3. Once I do that, I could figure out what sine of inverse cosine of 2 root 10 over 7 is, because now I know that sine is opposite over hypotenuse, which means my answer here is 3/7. All right, in the next video, we're going to dive more into these types of problems where we have to make our triangles. And what happens if we have to do it, let's say, algebraically.